Top 25 Python Developer Questions and Answers. In today's video, we'll be covering the top 25 Python developer interview questions and answers that can help you prepare for your next job interview. Whether you're a beginner or an experienced developer, these questions are designed to give you a clear understanding of Python concepts, best practices, and real-world applications. Stay tuned, take notes, and get ready to ace your Python interviews with confidence. 1. What are the key features of Python? Python is a high-level, interpreted, and dynamically typed programming language. Its key features include simplicity and readability, making it beginner-friendly. Python supports object-oriented, procedural, and functional programming paradigms. It has extensive standard libraries for tasks like file I/O, networking, and web development. Python's interpreted nature allows code to run line by line, simplifying debugging. It is portable across platforms and integrates well with other languages. Additionally, Python supports automatic memory management via garbage collection. Features like dynamic typing, high-level data structures, exception handling, and a large developer community make Python suitable for web development, data science, automation, AI, and scientific computing. 2. What is Python interpreted language? Python is an interpreted language, meaning the code is executed line by the Python interpreter rather than being compiled into machine code. This allows for faster development and easier debugging because errors are detected at runtime, and there's no need for a separate compilation step. It also makes Python platform independent, as the interpreter handles code execution on different operating systems. Being interpreted allows for dynamic execution and flexibility, enabling features like dynamic typing and runtime evaluation. However, interpreted code can run slightly slower than compiled languages. Python balances this with readability, simplicity, and a rich ecosystem of libraries for various applications. 3. Explain Python's memory management. Python manages memory using a private heap that stores all objects and data structures. The Python Memory Manager handles allocation and deallocation of this memory automatically. Python uses reference counting to track the number of references to objects, freeing memory when no references remain. Additionally, it implements a garbage collector to detect and clean up circular references that reference counting cannot handle. Developers don't need to manually manage memory, but understanding memory-intensive operations can improve performance. Python's memory management ensures efficient usage of system resources while minimizing memory leaks, allowing developers to focus on application logic rather than memory allocation and deallocation. 4. What are Python's data types? Python has several built-in data types, including numeric types, int, float, complex, sequence types, list, tuple, range, text type, str, mapping type, dict, set types, set, frozen set, and Boolean type, bool. Lists are mutable sequences, while tuples are immutable. Sets store unordered unique elements, and frozen sets are immutable sets. Dictionaries store key-value pairs with fast lookups. Python also supports bytes and byte array for binary data and none type to represent null values. Each data type has its methods and operations, allowing versatile handling of data. Understanding these types is essential for efficient coding, as they define how data is stored, manipulated, and accessed in Python. 5. What is the difference between list, tuple, and set in Python? Lists are ordered, mutable sequences allowing duplicate elements, supporting indexing and slicing. Tuples are ordered but immutable sequences, meaning their elements cannot change once assigned. Sets are unordered collections of unique elements without indexing or slicing. Lists are typically used when data may need modification, while tuples are used for fixed collections for performance and data integrity. Sets are ideal for membership testing, removing duplicates, and mathematical operations like union and intersection. Lists and tuples maintain element order. Sets do not. Choosing the right structure depends on requirements like mutability, order, and uniqueness. Understanding their differences ensures efficient data manipulation and optimized performance in Python programs. 6. What are Python's mutable and immutable data types? Mutable data types in Python can be modified after creation, meaning elements can be changed, added, or removed. Examples include lists, dictionaries, and sets. Immutable types cannot be modified once created. Attempts to change them result in new objects. Examples include tuples, strings, frozen sets, and numbers. Mutability affects memory usage, performance, and behavior during function calls. For instance, mutable objects can lead to unexpected side effects when passed as arguments. Immutable objects are safer in multithreading because they prevent unintended changes. Understanding mutability helps in choosing appropriate data structures and writing efficient, predictable code, especially for large applications or data-sensitive programs. 7. Explain Python's pass-by-value and pass-by-reference concept. Python uses a mechanism called pass-by-object reference. Objects are passed by reference, but the reference itself is passed by value. Mutable objects like lists and dictionaries can be modified inside a function, affecting the original object. Immutable objects like integers, strings, and tuples cannot be changed in the function. Any modification creates a new object. This behavior combines aspects of both pass-by value and pass-by reference, depending on object mutability. Understanding this distinction is crucial to avoid unintended side effects. Developers can use techniques like copying objects or returning modified data to control data flow, ensuring predictable and maintainable Python code. 8. What are Python's decorators and how do you use them? Decorators are special functions in Python that modify or enhance other functions or methods without changing their original code. They are applied using the @decorator_name syntax above a function definition. Decorators can add logging, authentication, timing, or input validation to functions. They are often used in web frameworks like Flask and Django for routing and middleware. Python supports nested and parameterized decorators for flexible behavior. Internally, a decorator takes a function as input and returns a new function with added functionality. Using decorators promotes code reuse, modularity, and clean design, allowing developers to implement cross-cutting concerns without cluttering core logic. 9. What is Python generator and yield keyword? A generator is a special type of iterator in Python that produces values lazily, generating items one at a time instead of storing the entire sequence in memory. The yield keyword is used inside a function to produce a value and pause the function state, allowing resumption later. Generators are memory efficient, ideal for large datasets or streams. They can be iterated using loops or next calls. Unlike normal functions, generators do not return all values at once, reducing memory usage and improving performance. Common use cases include reading large files, infinite sequences, and pipelines where items are processed sequentially on demand. 10. Explain Python lambda function with example. A lambda function is an anonymous, single-line function defined using the lambda keyword. It can take any number of arguments but returns only one expression. Lambda functions are useful for concise, inline operations, especially with functions like map, filter, and sorted. Unlike regular functions defined with def, they have no name unless assigned to a variable. Example: square equals lambda xx *** 2 defines a function to square a number. Lambda functions improve readability for small operations but are not suited for complex logic. They are widely used in functional programming patterns in Python, providing compact and efficient code. 11. What is Python's global interpreter lock-gil? The global interpreter lock-gil is a mutex in CPython that allows only one thread to execute Python bytecode at a time, even on multi-core systems. This ensures thread safety for memory management and internal data structures. While the GIL simplifies development, it limits true parallelism for CPU-bound tasks, as threads cannot fully utilize multiple cores. For I/O-bound tasks, multithreading works efficiently because threads spend time waiting for input-output operations. Alternatives like multiprocessing, C extensions, or implementations like Jython and IronPython bypass GIL restrictions for parallelism. Understanding GIL is essential for optimizing Python applications requiring concurrency or high-performance computing. 12. How do you handle exceptions in Python? Exceptions in Python are handled using try, except, else, and finally blocks. Code that may raise an error is placed inside the try block. Specific exceptions are caught using except clauses, allowing graceful error handling. The else block executes if no exception occurs, while the finally block always runs, typically for cleanup like closing files or releasing resources. Python supports custom exceptions by inheriting from the exception class. Proper exception handling improves code robustness, prevents crashes, and enhances user experience. Best practices include catching specific exceptions, logging errors, and avoiding bare except clauses to maintain predictable and maintainable code. 13. What is Python's iterators and iterables? An iterable in Python is any object that implements the __iter__ method or supports the sequence protocol. Examples include lists, tuples, sets, and dictionaries. An iterator is an object representing a stream of data, implementing the __next__ method to retrieve elements sequentially. Iterators allow lazy evaluation, reducing memory usage for large datasets. You can obtain an iterator from an iterable using the iter function and iterate through elements with next. Python's for loop implicitly handles iterators. Understanding iterables and iterators is crucial for designing efficient loops, generators, and pipelines, especially when dealing with large-scale data processing in Python. 14. Explain Python's args and quargs with example. Args and quargs allow flexible function arguments in Python. *args collects extra positional arguments as a tuple, while quargs collects extra keyword arguments as a dictionary. They enable functions to accept variable numbers of inputs without explicitly defining each parameter. Example: defgreet, *names, Messages allows calling greet, Alice, Bob, morning equals good morning. Inside the function, names is Alice, Bob, and messages is morning, good morning. Using them increases code flexibility and reusability. They are commonly used in decorators, API wrappers, and functions needing optional arguments. Proper use enhances maintainability and readability of Python code. 15. How is Python different from other programming languages? Python emphasizes simplicity, readability, and rapid development compared to languages like C++ or Java. It is dynamically typed, interpreted, and garbage collected, requiring less boilerplate code. Python supports multiple paradigms, including object-oriented, procedural, and functional programming. Its extensive standard libraries and third-party modules accelerate development in web development, AI, data science, and automation. Python has a large community, making support and resources easily available. Unlike statically typed compiled languages, Python trades raw performance for developer productivity, though libraries like NumPy or Cython can mitigate this. Its clean syntax, readability, and versatility make Python an ideal choice for beginners and professionals alike. 16. What is Python module and package? A Python module is a single .py file containing functions, classes, and variables that can be reused across programs. A package is a collection of modules organized in directories with an __init__.py file. Modules promote code modularity, readability, and reuse. Python provides built-in modules like OS, sys, and math, and developers can create custom modules for specific functionality. Packages allow hierarchical organization of modules, supporting large-scale applications. You can import modules using import module_name or from module_name import function. Understanding modules and packages is essential for structuring Python projects, improving maintainability, and avoiding code duplication. 17. What are Python's built-in functions? Python provides over 70 built-in functions for common tasks, eliminating the need to write basic operations from scratch. Examples include len, for length, sum, for addition, max, and min, for extreme values, sorted, for sorting, and type, for type checking. Functions like map, filter, and zip support functional programming. Input, output operations are handled by input and print. Python also provides open, for file operations, range, for sequences, and enumerate, for index loops. Using built-in functions improves code efficiency, readability, and reduces errors. Mastery of these functions is crucial for Python developers to write concise and optimized code. 18. How do you manage memory leaks in Python? Python uses automatic garbage collection, but memory leaks can still occur, usually due to circular references or long-lived objects. Detecting leaks involves monitoring memory usage with modules like GC, ObjGraph, or memory profilers. Techniques to manage leaks include breaking circular references, deleting unnecessary objects with del, and using context managers to handle resources like files or sockets. Avoid global variables for large objects and prefer local scopes. Python's weakref module allows references without preventing garbage collection. Regular testing and profiling ensure memory efficiency, especially in long-running applications. Proper memory management improves performance, stability, and prevents crashes due to excessive memory consumption. 19. What is Python's multithreading and multiprocessing difference? Python's multithreading allows concurrent execution of multiple threads within the same process, sharing memory space. However, the global interpreter lock (GIL) restricts true parallel execution for CPU-bound tasks. It's ideal for I/O-bound tasks like network requests. Multiprocessing, in contrast, uses separate processes with independent memory, allowing true parallelism for CPU-intensive tasks. Communication between processes uses inter-process communication, IPC, mechanisms. Multithreading has lower memory overhead and faster context switching but limited CPU performance due to GIL. Choosing between them depends on the workload type. Proper understanding helps optimize Python applications for concurrency, improving efficiency in real-world systems and data-intensive processes. 20. Explain Python's list comprehension with example. List comprehension is a concise way to create lists in Python using a single line of code. Its syntax is expression for item in iterable if condition. It improves readability and reduces boilerplate loops. Example: x *** 2 for x in range 5. If x%2 equals 0, produces 0, 4, 16. List comprehension supports nested loops and conditional expressions, allowing complex list generation in a readable format. Compared to traditional loops, it is faster and more Pythonic. Comprehensions also work for dictionaries, v for k, v in iterable, and sets, x for x in iterable, enabling efficient and elegant data transformations across different Python collections. 21. What is the difference between shallow copy and deep copy in Python? A shallow copy creates a new object but references the original elements, meaning changes to nested objects affect both copies. It can be done using copy.copy. A deep copy creates a new object and recursively copies all nested objects, ensuring independence from the original, using copy.deepcopy. Shallow copies are faster but risk unintended modifications in nested data. Deep copies prevent side effects but consume more memory and time. Understanding this distinction is crucial when manipulating complex structures like lists of lists or dictionaries of objects. Proper copying ensures predictable behavior and avoids bugs in Python programs. 22. What are Python's magic methods? Magic methods, also called dunder methods, are special methods with double underscores, like underscore underscore init underscore 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 zero underscore 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 add underscore underscore and underscore underscore len underscore underscore. They allow customizing object behavior for built-in operations. For example, underscore underscore init underscore underscore initializes objects, underscore underscore str underscore underscore defines string representation, and underscore underscore add underscore underscore enables operator overloading. Magic methods are essential for implementing custom classes that behave like native Python types. Using these methods improves code readability, maintainability, and integration with Python's data model. Developers can define object behavior for arithmetic operations, comparisons, iteration, context management, and attribute access. Mastery of magic methods enhances object-oriented programming skills and allows building advanced Python applications. 23. How do you work with files in Python? Python provides built-in functions for file handling. The open function opens a file in different modes like read, R, write, W, append, A, and binary, RB, WB. File reading can be done using read, readline, or readlines. Writing is done with write or writelines. Using with open, as file, ensures automatic resource management, closing files after operations. Python also supports file manipulation via OS and showtil modules. Exception handling ensures safe operations and prevents errors. Working efficiently with files is essential for data processing, logging, configuration management, and building applications that interact with persistent storage in Python. 24. What is Python's decorator chaining and its use cases? Decorator chaining refers to applying multiple decorators to a single function, allowing sequential modifications. They are applied from bottom to top. Syntax at dec1 at dec2 deffunc. Each decorator wraps the function, adding layers of functionality. Common use cases include authentication, logging, caching, validation, and profiling in web frameworks or APIs. Chaining promotes modularity and code reuse without modifying core logic. Decorators can be parameterized to accept arguments, increasing flexibility. Understanding decorator chaining helps design scalable and maintainable Python applications. It enables separation of concerns, improves readability, and allows applying cross-cutting functionalities in a clean, Pythonic way. 25. How do you optimize Python code for performance? Optimizing Python code involves multiple strategies. Use built-in functions and libraries like numpy for heavy computations. Replace loops with list comprehensions or generator expressions for efficiency. Minimize global variables and reduce function calls in performance-critical sections. Use appropriate data structures, such as sets for membership tests or dictionaries for fast lookups. Profile code using cprofile or timeit to identify bottlenecks. Apply caching via functools.lu_cache for repeated computations. For CPU-bound tasks, use multiprocessing, while for I/O-bound tasks, use asynchronous programming. Writing clean, efficient, and memory-conscious code ensures better performance, scalability, and responsiveness in Python applications. That's it for today's video on the top 25 Python developer interview questions and answers. We hope these insights help you prepare effectively and boost your confidence for upcoming interviews. If you found this video helpful, make sure to like, share, and subscribe for more tech tutorials, interview tips, and programming guides. Comment below with your favorite question or any Python topic you want us to cover next.